As you can see here, I decided to have to give you quite a broad term title, which is Terminological Creativity, because to be honest, I didn't want to scare you off today, because the application field that we're going to be talking about today is organic chemistry. And since I was scared myself when I was doing my PhD on organic chemistry, I thought, okay, I need to have a little bit of audience today. So I'm going to try not to scare you off with such a technical application field. So first of all, very quickly, there's a very short, very quick outline for today's presentation. First of all, I'm just going to be explaining why I decided to talk about organic chemistry and about terminology as such. I will be giving you a bit of characteristics of organic chemistry as well, because you will see that it's quite a complex field. We will be talking a bit about the history of terminology so that you understand a little bit the theoretical background and where I'm coming from when I decided to work on the specific research purpose that I will be describing today. And then, of course, which is probably the most exciting bit, we will be talking about variation and lexical creativity. So let's talk a little bit about the rationale. So first of all, okay, this is a little bit of my, I would say, guilty pleasure, because I thought, okay, I have worked in many topics on terminology. This is what I was initially trained. Dawn was explaining that I was working in loads of fields, which is true, because I used to work in a very kind of interdisciplinary school back in Paris, and so we were working on intercultural communication, on translation, on machine translation, and so on. So I had to basically gain a bit of expertise, but my initial training, and especially my PhD, was in terminology, and especially in corpus-based terminology. So just to give you a little bit of background, and so I've decided to talk about this because of the complexity of organic chemistry, but also to show you that despite this complexity, there can be some very nice, how should I say this, some linguistic beauty in this sort of technicality, basically. So just to give you a little bit of context here. So my PhD, which was done a long time ago, please don't judge me on this, was basically dealing with a large-scale analysis of specialized discourse. So basically, we are looking at how people interact within the workplace and in given social professional communities. In this instance, in organic chemistry, in order to highlight the indeterminate nature of organic chemistry and its multidimensionality. I'm going to explain this a little bit and to give you a little bit of background. So basically, when I was looking for, when I was doing my MLit, I was looking for a subject for my PhD, and I was approached by a team of organic chemists that were coming from the University of Namur, which is a Belgian university, and basically they came up to me, they were looking for a terminologist and saying, we need an expert in terminology to build a terminological resource in organic chemistry. I was a bit surprised because organic chemistry is considered as a hard science. It has been there for many decades. I knew that the terminology would be quite fixed in that field, and I was like, okay, why do I have a chemist that is actually coming to me and asking me to create a resource? So basically, after discussing with the team, they told me, well, we have massive communication problems in organic chemistry. Basically, our chemists use different terms, different definitions, but they don't put the same concepts and the same meaning behind those concepts, basically. So we need to find a way to create a resource where we kind of streamline, where we define basically how terms should be used. So I was a bit puzzled by this, so I thought, okay, it might be interesting to do a PhD on this. So I started looking a little bit more about the concept. So this is one thing, just to give you a bit of context. Now, the complexity of organic chemistry, I'm just going to show you very quickly an example of the term, of a term that is being used in organic chemistry, and you will understand straight away. Ta-da! I'm not going to try to pronounce this, but these are the typical organic names that you can have for organic compounds, basically. And of course, there is the difficulty of understanding these, but also there is another question is, how do we train future chemists basically to be able to handle that kind of information. And this was one of the purpose of that team in the University of Namur that came to me, because they were also thinking we need to create resources so that our future, students that are going to be graduating have, of course, the best linguistic tools and conceptual tools, basically, to be able to, understand the field, communicate, be able to publish, make discoveries, and so on. So that's one thing. So this is for the complexity. Now, what is interesting as well is that chemistry and organic chemistry can be considered as one of the most standardized language in the world. Okay, so here I'm clicking again, and I am going to be actually presenting a little bit how it works and how this standardization works, and what institution is behind this, but it is considered as one of the most standardized language. So suddenly I'm a little bit puzzled, because I have a team of linguists who are telling me, well, chemists don't know how to communicate together because they don't use the same terminology, the same words. And at the same time, I'm being told this is the most standardized language in the world. So what is happening here, and what can we make of this, basically? Now, also, why this topic? Well, I just wanted to very quickly point out the importance of the subject. Obviously, we're going to be using organic chemistry in loads of different fields, in chemistry, when we are creating medication and things like this. But also, I just wanted to give you a very recent example. I was actually contacted a few years ago by the Terminological Board of Ireland. I'm not going to pronounce the name, but basically they contacted me and we had a chat about chemistry, because they were telling me that since Irish has become a kind of a working language for the European Union since 2022, basically they are urged to translate a huge amount of technical documents, and one of the most difficult documents that they have to translate are precisely chemistry. Why? Because those terms do not exist in Irish. Some of them do not exist. So we had a chat, and I actually did a presentation because they wanted to understand the rules behind the motivation and the creation of those new terms. So it is very much still a very actual and current topic there, and so I thought it would be interesting for you to know this. Now, why terminology today? I would say, and it's a little bit of a bold statement, that I consider that there's a relative underrepresentation of terminology, at least I would say in a kind of UK/Irish context, compared, let's say, to France, Spain, Austria, where terminology is extremely important. We will see that loads of the references, the literature review, actually come from those countries, which kind of explains. But I thought it would be a nice opportunity here. And lastly, which are, of course, the main purposes that I worked on when I was doing my PhD, is that by working on this specific field, we are going to see that there are important theoretical consequences. And I'm going to explain this a little bit further. Basically, the idea is that I wanted to question the traditional dichotomy that exists between hard and soft sciences and how they are approached from a terminological perspective. The idea was also to question the general theory of terminology, and this is why I will be going back to the history of terminology so that you understand a little bit why I'm talking about this. And the idea was to show how new trends in terminology, and specifically socio-terminology, socio-cognitive approaches, and what we call in terminology a textual approach, which is basically corpus-based, have completely transformed the field and allowed us to work in extremely different manners today. Okay, so this was a very, very long rationale. I'm very happy that Chris told me that I have a lot of time to be doing this presentation. So let's move on. Okay, so we've seen the rationale now. And now we're going to be talking a little bit about organic chemistry, just to give you a bit of presentation there. So organic chemistry is, as I said, is quite extraordinary from one perspective, because we can consider that the field is governed, literally governed, I would say, by an extraordinary nomenclature system. And I'm going to try to explain this. It's also why extraordinary, because this is one of the most active, one of the most lively and collaborative system that exists in the world. Okay, so how does it work? So basically we have one institution, which is UPAC, which is the International Union basically of Pure Applied Chemistry. And this institution basically creates and disseminates all the recommendations and all the glossaries existing in chemistry in order to establish an ambiguous, uniform and consistent terminology in all chemistry related fields. Okay, why do they do this? Well, of course, for the sake of communication and clarity across sciences, that's quite obvious, but also because of the nature and the number of organic compounds being discovered every year. Okay, we have basically between at least 50,000 and 100 compounds discovered every year. And just to give you a little bit of information here, I thought it was quite funny. In 1880, we only had 12,000 known organic compounds. Then we moved a little bit further, like for example, in 1910, we moved to 150,000, and today we are talking about 15 million or 16 million of compounds. Okay, so this shows you the importance of dealing with such a huge amount of lexical units. Okay, and also I will discuss this a little bit further. There's a very recent characteristic which is the rise of structural diagrams, but I will explain that a little bit further. Now, how does it work? So basically, we know that all the compounds, but not only the compounds, the reactions, any chemical chemistry is going to be named through that UPAC nomenclature. Sorry. So now, how does it work? Just to show you how a compound is being named. So basically, the UPAC name usually is going to define 3 essential features. Okay. First of all, we always have a root or base, which is basically going to indicate the number of carbon atoms that we have in a structure. Okay, I'm just going to give you a quick look here. So as you can see, we have really a very strong typology there. Okay, if we have 1 carbon atom, you're going to start basically your compound by meth. If it's two atoms, S, etc., etc. Okay, and that goes along. It continues. So this is the root or the base. Then we're going to be looking at basically the functional groups, and this is going to be represented by either a suffix or any other linguistic elements. Okay, so I'm going to very quickly show you an example here. For example, if we have a functional group that is an alkane, then the word is going, the organic compound is going to be finishing by the suffix -an. Okay, if it's an alcohol, it's going to be finishing by -ol. So we can see here already very strongly how standardized those rules are and how terms are being created. Okay, so we are in a very kind of rigid perspective there. And finally, the last feature of the name, we are going to add any potential groups outside of hydrogen. Don't ask me why. I would be unable to remember why, but basically this is how it works. And this is what we get as a kind of final basically perspective. Okay, now why do we work like this? The idea is that basically for each name created, you will have a given structural formula, okay, and a given equation and a given line formula, which means that basically if you're being given the equation, you should be able to go back to the molecular formula. So this is the C3H6, for example, and this has only one concept, one name, which is cyclopropane, etc., etc. So again, we can see the density and the strength of that nomenclature. Okay, so this is basically how it works in terms of organic chemistry. I'm leaving that on the side for the time being, and now we're going to be talking a bit about the history of terminology. So, terminology has always existed, okay? For example, the very first nomenclature in chemistry was created by a French chemist, Lavoisier, actually, that was in the 18th century. We needed typologies in zoology. Has always existed. However, terminology as being considered as a scientific discipline was only born in the 20th century. Okay, so as the recognition of terminology as a field, a scientific field on its own, is very, very recent. We owe this to one person in particular, which is Eugen Wuster. I apologize if I mispronounced this, but basically, and who he is. So he is an Austrian engineer, basically. So he's absolutely not a terminologist or a linguist. And what he did is that he developed the first theory in terminology based on his own terminological experience. So how did he do this? He compiled a French and an English dictionary of standardized terms, which he called a machine tool. And his dictionary was so transformational that it started being used as a model for other technical dictionaries and also as the basis for the first theory in terminology. Okay, so once he did this, I'm simplifying a little bit here for the purpose of this presentation, but basically once he worked on this, because he was obsessed by streamlining communication and making it as unambiguous as possible. So basically, the main objective of his life became to standardize terminology in order to eliminate ambiguous terms from technical languages, and also, of course, to give terminology this famous status of a science that didn't exist beforehand. So how did he do this? Basically, he decided to develop standardized international principles to describe and record those terms. He decided to formulate general principles of terminology as well. He created a training center, which is called Infoterm, okay, with IVO rules in terms of terminology in order to be able to disseminate and coordinate this information. Just a small anecdote there, which is quite funny. Eugen Wuster was actually a big fan of Esperanto. And so when he was working on how to try to eliminate ambiguity among terms, he thought, well, we're just going to ask everybody to use Esperanto terms like this. There will be no kind of multilingual problems, no translation problems, because everybody, of course, this didn't work because Esperanto is a very complicated language. And so he kind of turned into standardization, basically. Now, let's have a look at the general theory of terminology to understand how terminology from a theoretical perspective has been shaped for a long, long time. So first of all, again, I'm simplifying a little bit here those principles, but anyway, so first of all, the first I would say principle is the importance of the concept. Okay, this is what we call the onomasiological approach. We need to keep in mind, to bear in mind, that we wanted to make terminology a recognized scientific field. So we needed to move away as far as possible from lexicology or even applied linguistics. So the idea was that the main concept or the main object of study of terminology would always be the concept. Not the terms in a way, but the concept. So it's the idea that the concept, the idea comes first, and then we have the denomination. And of course, we're starting to see that this is a little bit complicated. Then second principle, concepts should be clear-cut always. And they should never be studied in isolation in the sense that they should always belong to what we call a concept system or a conceptual tree, okay? Just giving you an example, if I take a simple term like an apple, what is an apple? Well, an apple is a sort of fruit. So we can put it in the kind of concept tree of fruit, and we're going to have fruit on the top, and then we're going to have apples, we're going to have bananas, we're going to have like loads of other fruits, okay? So basically the idea is all the concepts of a given technical field are always going to be put together. So just to give you a very quick image, and I'm very sorry I didn't manage to make it bigger on my presentation. This is a conceptual tree that I derived from my corpus-based analysis. So basically, I looked at the conceptual relationship existing between terms when I was analyzing my corpus, and I came up with a conceptual tree. Here you don't see it, unfortunately, on the screen, but this is a conceptual tree of organic chemistry. It can be divided in two subtypes, an elementary organic reaction, and a complex reaction, and then you've got loads of subtypes, basically. So this is the second very strong principle, is that we work through concept systems. Third of all, definitions of terms must be intentional. What does that mean? So I'm going to give you an example here, if it works. Okay, and it's very small again, I do apologize for this. So basically, it's the idea. The same way I defined a few seconds ago that an apple is a sort of fruit with specific characteristics, then we can do the same, for example, as here with an organic reaction. An organic reaction is basically a reaction in which a chemical species is going to gain one or two atoms, etc., etc. So we have a class of objects, basically the reaction, and then we have characteristics. So this is what we call an intentional definition. And according to Buster, all those definitions should actually follow this principle, okay? Then number 4, which is perhaps the most problematic principle, he considers that each concept should be designated by only one term, one denomination, and each term should only be referred to only one concept. This is what we call the univocity principle, which basically means that synonymy and polysemy are completely banned. Okay, so we're starting to see that there's more and more problems in this theory. And last principle, terminology is not there to study language development or evolution. This is what linguistics does. So we are just going to be looking at a synchronic analysis of terms, basically how terms work today now, because again, the only purpose of terminology is to have a clear, unambiguous communication, okay? So we can see that we are in a very pragmatic setting here. Now, what happens is that for 20 years, that general theory of terminology was not very much criticized, okay, because the main concern of terminologists back then was to preserve terminology as an official discipline. So we couldn't touch basically those principles because we didn't want to jeopardize the recognition of terminology as a scientific field, as a new field, very recent one, okay? However, with the advent of computers, with new approaches in terminology, basically influence from social linguistics and things like this, of course, criticism started to emerge. Because suddenly linguists and terminologists realized that this was a kind of utopic system, an ideal topic in terminology, but of course what we have in real life is variation, is synonymy, is a diachronic approach, and so on. So I have highlighted in blue in particular the approaches that I have been using in my PhD, but generally speaking in all my terminological work. And so just to give you a few examples, for example, the socioterminology approach there, if we open this, well, basically Godin is telling us that the concept cannot be a fixed entity because it moves, because it is built in discourse, and therefore it is going to be prone to social and historical factors, okay? Terms evolve, languages evolve, and so we cannot just fix terms in this kind of stock boxes, basically. He also said that the analysis of terms should take place in the middle of social interaction. So he was one of the first terminologists who actually went in on the field and started recording people in the workplace, which is a little bit what we're doing now in our project, to understand how terms are being used, how they are being, if there's variation and so on. And of course, he has tried to rehabilitate a diachronic approach of terms, which sounds quite normal to me. We have also the sociocognitive terminology, which is represented by Rita Temmerman. And so very interestingly, and especially in the views of organic chemistry, she worked a lot in life sciences, and she looked at how terms were being categorized and how they're being defined, okay? So she was very critical of the intentional definition, because basically she was saying that terms are too complicated to be put in those kind of like tiny boxes of a class object and semantic characteristic defining the terms. So she offered to create another type of definition. She worked around cognitive concepts like prototypical concepts. I'm not going to go into this because that would take me ages. And she also expanded the notion of conceptual relationships. So instead of just looking at a fruit, an apple is a sort of fruit, she started looking at all the other type of relationships, functional relationships, causal relationships, temporal relationship that exists, so that we can have actually a more extended representation of a technical field. And last but not least, the textual approach, and here I'm quoting Boker and Pearson, Condamine. As you will see, loads of actually French names, Didier Bourrigaud, Gilles Osnac, Gilles, sorry. Very wide community coming from the French research, which is where I was trained, so that's why probably you have those kind of unknown names here, and which is the textual approach, which is typically a corpus-based approach, with the idea that terms should be systematically analyzed in context, okay? Not in isolation in the middle of conceptual trees, but again, in discourse and in social interactions, okay? Now, so of course, as you can see, we have massive criticism there, and this had a transformational impact on terminology and on terminography as well, which is how we create dictionaries. So what happened there is that obviously we had renewed and innovative methodologies and new terminographic resources. We started, for example, not just looking at definitions, but also including collocates, including loads of type of conceptual relationships. We included synonyms and things like this because we believed that we needed more terminological information than just a definition. Now, very surprisingly, we see through those approaches that we can see that variation exists, synonymy exists, like basically that ideal world that Eugen Wester created is not the reality of how technical languages work. However, when I started my PhD, there was still a very wide belief that variation, synonymy, and diachronic approaches could only be applied in a way to soft sciences. What I mean here is that it was accepted that if you work in economy, if you look at the language of economy, if you look at the language of psychology, then because there's human interactions, because those fields are supposedly more messy, in a way, less organized than hard sciences, then this is why you have variation. But that variation and that linguistic creativity that I am going to be, hopefully, if I have the time, that I will have the time to present today, that basically they don't exist in hard sciences because we have standardized terms, because we have nomenclatures, because we have, you know, this very strict approach around technical languages. So this is me basically having, on the one hand, theorists telling me, well, there's no variation in hard sciences, but at the same time, a whole team of chemists, experts, who came to me from Belgium telling me, well, our chemists do not understand each other because terms are vague and because definitions are vague, okay? So I was like, okay, let's have a look. And this is how I built basically the project. So I decided to implement a corpus-based approach. What I mean by corpus-based is not corpus-based as, you know, against corpus-driven, but just like a corpus approach, basically. So how did I work? So I use a relatively classical corpus design criteria. I'm not really going to expand on this because I believe all of the people listening here are quite familiar with those. There's slight variations, adaptation when it comes to terminology, like we look at the level of communication of the audience and things like this, but we work in terms of representativeness, in terms of balance, in terms of what type of population are we looking at, in terms of sampling, so all of this works. Now, I decided to work on what I call a twofold corpus. Okay, here we are, and it's very small. Again, I do apologize. So basically, the idea was for me to build actually two subcorpora. One of specialized corpus, because I wanted to look at how experts interact with other experts. So this was essentially made of scientific publications. But I also wanted to understand how experts teach organic chemistry to basically university students. So I also built what I called a pedagogical corpus. So basically we are dealing here with 2-3 million words in total that were built. Unfortunately, yeah, you don't really see here, it's a little bit too small, but basically this is the corpus. And now how did I work? Well, basically I I applied what didn't exist back then, but what could be what is has been named today by Turco as the pattern-driven approach, which is basically a mix between the corpus-based and the corpus-driven approach. Okay, so I used very classic corpus for functionalities, looking at frequency list, n-grams, collocate, and so on. I ended up with 33,000 terms. And I ended up only looking at 50, I think, at the end of the day. So, but that shows you the extent of the lexical units that you can find. I also used basically linguistic markers or textual markers. Those textual markers are basically, I don't know if I did. Yes, I did, but it's very small again. So basically, how does it work? Because conceptual relationships are so important in organic chemistry, and because my main purpose was to investigate if definitions were indeed loose and vague, the definition used by chemists, I started looking into the corpus. I wanted to identify what we call rich context in terminology. So basically, I wanted to kind of filter down the information to where I could find definitions or to where I could find semantic relationships, basically. So for example, when I was saying an apple is a sort of fruit, then I have a perfect marker. So I investigated a form of, a sort of, a type of is being defined, for example, etc., to be looking at definitions. And of course, since I wanted to work on relationships, I worked on things like is a sort of, is a type of, etc., etc. So this was one approach that is quite known in terminology as well. And the last approach, which I will be showing as well in a few seconds, I use what we call patterns of variation, and this comes from especially Béatrice Daye, Haber, Jacquemin, and Royauté, and it's the idea of looking basically at n-grams, but also specific syntactical patterns that you apply within the corpus to see if you have variation, basically variance in the corpus. So, okay, let's talk finally about variation and creativity. So I'm not going to be showing you, I've decided today to focus on the results and not that much on the corpus. But please keep in mind that everything that I found here came literally from the analysis of the corpus. Okay, so and what is interesting is that we are going to have extremely unusual, surprising situations. So first of all, what I noticed is what I call competing names, basically, which basically means the fact that we have loads of synonyms being used, which is quite surprising because given the fact that we are working within a nomenclature, there should be literally no competing synonyms there. However, what is interesting is that when I was looking in a corpus, I actually found three types of names. Systematic names, which are the names that are being created according to UPAC rules that I have been describing. We've got what we call the trivial or the common names, okay? Typically common salt, iodized salt, sea salt, which actually comes from kind of like, general language, basically, but are still used by the chemist. And we have, which is very interesting, semi-systematic or semi-trivial names, which are a mix of names created by UPAC rules and a mix of names coming from the general language, okay? And what is interesting is that we have at the same time systematic names and trivial names that refer to the exact same concept. So that was the very first surprise. I was like, this is interesting for such a standardized language. Now, why do we have this variation factors? I thought it would be interesting just to kind of have a quick look. Part of the common names that we have actually that are being used in chemistry actually come from the very first chemical nomenclature that was created, as I mentioned, by Lavoisier, Guiton de Morveau, Fourcroy, and Berthollet. So basically, this very first nomenclature was created in the 18th century. Those chemists wanted to kind of make sure that I had a very clear naming system, because back then in the 18th century, you still had a mix of science and magics, basically, or what was considered as magics. And the idea was to come with a very clear naming system. So it's quite interesting to see that some of those names were actually created and taken again basically in the nomenclature. So I just want to give you one example of the word methane here, which gives methanol and methylene, and actually the compound methy, which has a kind of scientific basically seems to be a very scientific suffix there basically, or root or whatever, basically actually comes from one word, which is forest wood, which means timber material. It comes a lot from Greek. There was a lot of Latin, but a lot of Greek influence, and so it comes from the word. I'm not going to pronounce it, and so we are starting to see that we have loads of term creation by back formation. So we don't use the UPAC rules, but we actually go and look for historical names to bring them back into the nomenclature. So that was quite a surprise, but also a confirmation that nomenclatures are places of open intellectual, linguistic, and historical conflicts and debates, and therefore there is variation even in the most standardized languages. Now, just to give you other examples here. Basically, why do we have this variation? Well, because of the inherent complexity of the nomenclature, and I'm going to be quoting here Fradet, who is saying, for example, he's looking at dendrimers, and he's saying, naming dendrimers by the rules of the systematic nomenclature of organic chemistry is in principle possible, but depending on their size, and more so on the exact position of the principal functional group, it would be cumbersome, okay? So suddenly chemists are also realizing that there is complexity in those UPAC rules, and therefore sometimes it's just easier to go for a common name. So just to give you another example here, I'm sorry, it's very small again, but here, for example, we learn that dendrimore was first called cascade molecules because of the shape, basically. So we have a very nice metaphorical structure there. Then it became harboral, basically, which was derived from Latin harbor, which means tree, basically. And dendrimore then was created because it is derived from the Greek word dendrum, which means tree. So we can see the kind of historical that the historical variation of the terms, and now the official term in the nomenclature is dendrimore. So it's quite interesting to see how we have this kind of evolution. Now, what else? We have resistance as well from organic chemists, because the UPAC rules are so difficult. As I said a few seconds ago, it is easier to go for common rules, basically. And this is what Jorns is saying. It is understandable when publishing scientists who are pushed for time and funding do not want to use time-grasping UPAC nomenclature and terminology, and nomenclature and terminology compete poorly with these emotional roller coasters, so the pleasure of actually naming your own discovery and finding your own term, okay? So we are seeing here why it is important to be studying those terms in the middle of social interactions there. Okay, I've done that already. Okay, and lastly, to finish on those competing names, basically, another discovery is that there's also, because chemistry is an interdisciplinary field, then we have loads of industry-related factors. So not only do we have systematic names, but we also have common names, and then we have the names which are given by the industry, okay? So suddenly, instead of having one official name for an organic compound, we can end up with 4, 5, or 6 different synonyms. So we are completely against the rules, the principles of the general theory there, okay? Now, then I started looking, so after looking at lexical units, I wanted to understand, okay, to see if there was syntactical variation in the corpus. So this is where I used the patterns that I was, and the n-grams that I was mentioning before, I used typical markers that are considered as hedging devices, okay? Typically like, type, and so on, to understand. What we need to understand is that organic chemistry is so complex that it's sometimes impossible to define concepts or to describe concepts in a simple definition. So chemists, especially those who need to kind of disseminate the knowledge, need to use other linguistic techniques to be able to explain the nuances and that complexity. So suddenly I started looking into those markers, and it's extremely interesting because suddenly we see those typical official names: aldol reaction, manic reaction, River-Mortesky reaction. And suddenly in the corpus, we have loads of this kind of what we call an insertion variation, because the chemist is actually using a distancing strategy there. So we have aldol-like reaction, aldol-type reaction, manic-like reaction, manic-type reaction, which is a way for the chemist of saying it's like a sort of manic reaction, but not exactly. And you will never find a definition for those, but the like or the type allows the chemist to say, okay, this is the basic principle for this, but there's going to be a few differences. Okay, here I've just put a few concordances. You can see here how difficult it was to work on the corpus, because these are the typical, the technical language that we have. So that explains why it took me so many years to do my PhD. But as we can see, aldol-type condensations, first Murakami aldol-type reactions, etc., etc. Now, I was quite puzzled by this last one, reaction in a River-Mortesky-like fashion. I was like, this is quite unusual. And it's quite beautiful to find something like this in chemistry. So basically, I started looking at the marker fashion, and suddenly I discovered this. Reaction in a switch-like fashion, the reaction continues in a chain-like fashion, it proceeds in a zipper-like fashion, it processes in a step-like fashion, in a wave-like fashion, in a glutamate dehydrogenase-like fashion. So suddenly we are starting to see the creativity, this absolutely unexpected creativity. The main purpose of my research was to look into the vagueness of the concept being used and their multidimensionality. And suddenly I'm realizing that there's loads of creativity and loads of variation in what is considered as the most standardized language ever. And this is obviously due to a corpus, well, thanks to a corpus approach. Okay. Now, very quickly, because I would like to give a little bit of time for questions, I looked at lexical derivation as well. And so from official terms like acid catalysis or catalysis, we have acid catalyzed. From isotopic effect, we move on to isotopic effect. So it's quite interesting to see how chemists are going to move around those kind of grammatical functions. For example, isotopic labeling, which is an official concept with a definition, will become isotopically labeled, isotop labeled, etc. Same here with bond homolysis. We have to break a bond homolytically, etc., etc. So we see suddenly that there is a need to kind of provide some writing creativity when those concepts are being written, proposed in publications, or when they are being used in pedagogical high level, but pedagogical textbooks for students, basically. And finally, now I'm going to leave on side the multidimensionality, and I will just like to finish on this, because I think this was, for me, perhaps the most exciting discovery that I made when I was working on this is, and I went very far in the literature. So I found one concept which is given by Portelance, and as you can see, 1987. So this is not really new theory. And basically, there's one article talking about this, and that's it. And she called this incremental creativity. What does it mean? It means that in very complex, very technical fields, and particularly in English, there is this kind of regular progressive increase of a concept to represent, to kind of go along with the technicity of the field. So from a very simple, as you can see, alkylation term, which is technically an alkylation reaction, then we have an allylic alkylation, and I'm sorry for the pronunciation. Then we have and this is the power of the conceptual trees that I was telling you about as well. We have asymmetric allylic alkylation, catalytic asymmetric allylic alkylation, intramolecular asymmetric allylic alkylation, and so on. And we can continue. I don't have the time to talk about all of this, but we reach basically, for example, this one, palladium catalyzed decarboxylative asymmetric allylic alkylation. So here it's very interesting because we completely obviously we cannot work with 4 or 5 grams here. We have to go way beyond to be able to understand how creativity and lexical and this incremental creativity works. So very quickly, as a conclusion, basically what I discovered by looking at the indeterminate, the vague nature of organic chemistry is that actually chemists are extremely creative, and they use a very linguistic, what I call compensation mechanisms, to allow them to deal with the complexity and the vague nature of the subject. And they do this by using loads of competing names, synonyms or near synonyms, basically, by using syntactical variation, by using lexical derivation, and by using the incremental activity or increase that I just mentioned. And this is me being done. Thank you.